when I can.
Welcome, Dr. Sandy. Okay, fine. Now over to Aniska. I'll just introduce sir and we can start.
Okay, sir.
Yes.
Welcoming Mr. Shantipriya Parida, a senior scientist at Silo AI, Finland, currently making strides in the vibrant tech hub of Helsinki, Finland. He has completed his PhD from Utkal University and completed his postdoctoral fellow at Charles University, Czech Republic and IDEAP Research Institute. Artificial intelligence. He is a part of the innovative team at Silo AI. His work revolves around pushing the boundaries of AI, exploring novel solutions, and contributing to the cutting edge advancements in the field. Join him on this exciting journey at the intersection of generative AI and creativity. Over to you, sir.
Okay, thank you. Thank you for the introduction. So let me share my screen. Yeah, so is my screen is visible?
Yes. Make it full screen. Yeah.
Okay. So thank you. Okay, so can you start now?
Yes, we can start. Student will join. In the morning also, the break was there. You can start.
Okay, yeah, let's start. The topic is a retrieval augmented generation for Indic language. So this is relating to generative AI and LLM. So I don't know how many students have been acquainted with this topic, but I'll tell a little bit basics about the generative AI and LLM so that it will be easy to understand the topic. So let's start. So here is the agenda. So we'll talk about basically retrieval augmented generation, or which we call RAG overview, and about vector database, what is vector database, and vector embedding and search, and different components of RAG, and the evaluation. And also we'll have a short demo of how RAG works and how the RAG evaluation works with the conclusion. So these are the main broad topic. So feel free to interrupt me if there is some technical issue or anything I can look into. So before proceeding, let's discuss some of the terminologies which we will cover in this slide. So like vector database or vector embeddings. So this terminology which will help to understand the topics. So now some of the terminologies I'll try to explain here so that it will be easy, like the vector database. So normally, like when we know like the database, all we know that okay, we can store the data. So the data can be of different types, whether it will be a string or it will be some numerical data, or also maybe sometimes we can store some objects. So similarly, like in a vector database, so mostly as the name suggested, we can store vectors. So, but why this vector DB is important here? So one of the main reason is like we want to store mostly the embeddings. So embeddings, if somebody has acquainted or have some background in NLP, they know that the embeddings are nothing but some numerical representation of words or sometimes sentences. So those numerical representations, which we called as vector. So those we want to store in a place or the database, which So that's the reason we need this vector database. And the main idea is like we can store these embeddings and we can retrieve the embeddings so whenever required. So these vector embeddings, as I mentioned, these are nothing but the numerical representation of words. And also we sometimes called as chunking. So chunkings are nothing but like if you have a text, then we can split the text into different smaller unit we can call. So those are nothing but chunks because mostly we want to store either we want to store a long PDF or long document. So basically, we want to first split those into different chunks. So these chunks may be based on the number of tokens, like maybe 2000 or 1000, so or to 500. So those are called the chunkings. And also we see something we called like retrievers. So retrievers are nothing but these are the components which will retrieve those from vector embeddings. It will retrieve the matching embeddings. So those are called a retriever. So those we'll see in details in a subsequent slide. And also generators are nothing but which will generate the response, like when we have a query. So those queries generally will try to feed into a LLM or large language model to get the response. So that will be the job of this generator. And language model, so I hope if you have some idea about language models. So language models are nothing but mod, so the models like which can predict your next word. Assume you have a uh, you have a uh, you have a set of words, or the model is already trained with a lot of data. So data means it will be like assume we are talking about a Odia model or Hindi model. So these models means it will be already trained with a lot of monolingual data, and when you are passing a sequence, it can look into the sequence and generate the next word or next token. So that is a language model. So, or maybe we can go through a little bit about language model to understand what is language model. And when we call a large language model, which is very popular nowadays, in large language model, actually these are language models, but it will be in a very broad sense, like with millions or billions of parameters. So, uh, and mostly these large language models, actually nowadays it will be very popular because they are mostly using in generative AI. And also we sometimes will refer to as foundation models. So foundation models, those are actually the large language models. So these are already trained with a lot of data, or those are like a or we sometimes we call it like a pre-trained models. That means these models are already trained with a lot of data. And these are like a generalized model, so which we can use for any specific task. So task means it will be like we call it like a natural language processing. The task like maybe some we call it like a sentiment analysis. It's a task, or sometimes we call it is a machine translation. So like those are like different types of tasks. So those are job of the foundation model. I hope this terminology is a little bit clear, so that those will use in subsequent slides. Now, next comes to the before comes to RAG, we'll talk about little bit about the RAG, or why RAG, or why it is so popular, or why it is required. So first, we'll we'll discuss about like what are the limitations of large language models, and then why people are thinking about to resolve those things using RAG or retrieval augmented generation. So first thing is like these foundation models. Uh, mostly they respond with the answers related to the data they have seen. That means whenever you are asking any queries, so those are actually relating to those will be able to answer relating to the data they have seen, means they have trained with those data or those kind of data. And if you asking something very recent or recent queries, so mostly these large language models are failed. For example, assume like people say, okay, maybe OpenAI these have trained with, for example, like data up to 2021. Or then if you try to ask very recent questions, like some recent event happened maybe yesterday or last year, last week, or 15 days back, then those large language models will fail to answer your questions because they don't have those knowledge we got. And so that's the reason, one of the major reason, like when you want all your queries, like from the recent events or questions relating to any kind of domain, then these models maybe fail many times. And another reason is like uh, we can there is an option to fine tune these models. So fine tune maybe I can explain it a little bit about the fine tuning. So fine tuning means like your large language models, so they are like general models, so they have already have capability to solve any NLP task generally. But for example, like you want to your need is for some specific cases. For example, you want to for healthcare or maybe some specific financial domain. So those then these models may not suitable for you. That in that case, you need to do a fine tuning of those models. So mostly fine tuning with your data. Your data means your domain specific data. So for example, you want to build some applications which will be relating to finance. So then maybe you can collect some financial data and fine tune your model on the financial data. Then that can be answer all the financial related questions. But at the same time, so this fine tuning process, it's not very easy. First thing is that it needs additional data. That means for the specific domain you want to fine tune your model, then you need to first prepare the data for that specific domain. And also it incurs cost, and also it requires a retraining and model version change. That means you need to train your large language models, and also you need to replace your models, and which is not possible like every time. Like you cannot always fine tune your models. For example, again, few days your data got changed, then it's not possible again to fine tune it. It's possible, but again it will incur a lot of cost. So that is not a very practical solution. So these are like some of the issues why people are going for RAG, so that you don't have to retrain your model. You can use your existing model, which is trained on the data, but at the same time, so it can able to answer all the recent or related questions or queries. So all your problems will be solved. So that's why people are more interested, or nowadays more focusing on RAG. I hope there is some. I have given some idea like why RAG. Uh, so next, check the RAG workflow, or what are the main uh, components of RAG, and how they work. So if you see, this is the RAG workflow diagram. So maybe I can go through it, the diagrams. So you can see like there are different components, like this is something called vector DB. Vector DB is nothing but which is the storage which stores the vectors. And here you can see the embeddings. So embeddings, as I told, so those are like your from your queries. If you have a query and if you pass to an embedding models, So it will generate the embeddings. Excuse me. Yeah, embeddings. So those embeddings. So here something called, if you read a fetch relevant context. So fetch relevant context is nothing but it will, your embeddings will be matched with the embedding stored in the vector DB, and it will retrieve the similar embeddings. So that one will be fetch relevant context. So basically the workflow starts from the bottom. Bottom means first how the embeddings comes. So assume you have some PDF or some document. So this data can be in any form, whether it will be in PDF or it will be in doc or JSON or maybe some CSV. So whatever your data is there. So for those data, actually you can use one embedding model to get the embeddings of those data, and those embeddings you will store in a vector DB. So that will be your first part. And in the second phase, so that's why in the second phase the query comes. So if you see like a receive query from the user, so when user has received a query, so those queries it will convert it into an embedded query vector, preserving the semantics using an embedding model. So, so next, when the query comes, so it will try to get the embeddings from the queries, and it will fetch the relevant context or the matching context from the vector DB. And the query, so those which you call as the context. So the query and the context, those are passed into a LLM, and it will generate the response. So which we call like retrieve the top K relevant content from the vector database by computing similarity between the query embedding and the content embedding in the database. So similarity means it will be like based on the which we call like the semantically match. For example, like your database store a lot of information about, assume a fruits, and you are sending like mango, then all the related items relating to or similar to mango, those will be fetched. So similarly, like, so how this one will be there, so that mainly this happens using vector embeddings. So in the vector embeddings, it will be like in a latent the semantic space. So all the closing or the related embeddings, those will be false into uh, or those will be false as a cluster, and those will be like relating to each other. So something like whenever you try to search, so based on your query, so if your queries is like something you are searching like the maybe some tourism place. So, and your vector embeddings has stored lot of information about tourism, or the you have stored lot of PDFs about tourism, and those are stored already in the vectors. So those will be, now you are searching for a particular place, then those related items will be fetched from the relevant context. But how many those content will come, so that one is called like a top K. So the top K, you can define it. For example, the top K, the K value is 4, default is, so for example, you have set it defaulted to 4 or 5. Then the top 5 relevant content or the context, those will be fetched. So that is the idea. And when we say that, okay, query plus context, so those will pass to an LLMs. So this LLMs actually we'll see in some example like how we are passing. So mostly like you are passing query and the plus context. That means your query with some external information, and this LLM will use both like the query and using the context, and it will fetch the most reliable answers or the response for you. So that will be the main RAG workflow. So the most important thing, if you see, so there will be two part. One is the like the retriever part, like where when we are saying that, okay, we are fetching the relevant context, like the retriever part. And second part is the response generation part, like the when we are passing the query and context to the LLM to obtain the response. So that means here we have a retriever and also the response generators. So these two are the most important component of that. So So yeah, already I was mentioning. So these are two major RAG components. One is the retriever. So retriever like which will uh, which will retrieve the relevant context for the specific query or task, and a generator like generator is nothing but a typical like a large language model to where we are passing the query and it will obtain the response. Uh, So next, so we'll discuss more detail, little bit about like how these embeddings are stored and the role of this vector database and how this components really works. Because in the first phase, okay, we know this is vector DB or this is embeddings or this is LLM, but uh, exactly like how it works. So we'll see in subsequent slides. So first we'll talk about vector database. So here maybe you'll be more clear. So vector database, as I mentioned, it's a typical database that indexes and stores vector embeddings for fast retrieval and for similar matching. So if you look into like vectors, so vectors can be anything. For example, whether it will be like if you take like a text like using NLP transfer, sorry, this will be your NLP transformer model. So you can get some vectors. So similar not only for only text, whether it will be a audio or a speech signal, or it will be audio, or it will be like from an image. So all these actually you can convert into some vectors, and these vectors actually store in the vector database. So then why maybe one question arise like why we are storing in this in the vector form. So the main reason like that the retrieval will be fast, so that we can, whenever we want to search something from the vector DB, so it will be really fast. And the power of vector database lies in the unique data indexing and query technique. So indexing, you know that like so when we say that the indexing is nothing like a uh, when you store this informations, okay, it will be just like a, some metadata we can call. Like exactly we know that okay, we do some kind of indexing so that whenever we are trying to search, then the search process will be faster. And the vector database are engineered to perform high-speed similarity searches in massive data set. So when this data vector database assume it contains, it can store so million of records, and whenever you want to search something like based on your query, then it can able to retrieve your similar documents very fast. So that one will be one of the advantage. So, and there are like different vector DBs are available like in commercial. So commercial market, like you might have heard something about Viviet or maybe Chroma or Kindra. So all are like vector DB. So based on their algorithms like to storing the content and retrieving. So people are use different vector DBs. And this vector database actually they have a lot of application. The vector database they are used in AI or machine learning or NLP and image recognition. So they have a lot of applications of the vector database. So I hope vector database is a little bit clear. So mostly those are like this embeddings we store in a storage which we called vector database. And this vector embeddings, maybe you have some curiosity like how it looks or how these embeddings are. So if you look into, as I said, these embeddings are nothing but like a all the words or sentences we converted into a some numerical representation like in the vectors. So these vector embeddings are these are nothing but a way to convert words and sentences and other data into numbers. And the most important thing is that it can capture some kind of relationship. So if you look into like in the image, like in the there will be like two clusters are there. Like if you look into like animal, all the related like wolf, dog, cat, kitten, so those are like close to each other. Like here in a latent or semantic space, if you see the fruits like banana, apple, so those will be like very close to each other, or they are like forming a group or clusters. So now if somebody want to search like relating to a specific word relating to animal, then obviously actually these terms will be fetched. Or if someone will be like relating to fruits, okay, this will appear like banana, apple. So that is the what you can call, that is the like the vector embedding storage representation, and the way it retrieve the document. So for example, and next question, like how when we say like the similarity, like how we measure those, or how the similarity is evaluated. So those actually mainly we use different kind of distances. So if you look into like vector search or distance matrices, like when we saw like cosine similarity or different distances like Manhattan or Euclidean, so those actually based on this. So for example, like how we know that, okay, the new words which will be close to each other, that will be based on this cosine similarity or the distances. It will measure the distances. So whenever any, for example, any new words is there, first it will check like that, which one is very close to each, and based on that it will try to fetch. So that will be based on the distance matrix. And all these vector DBs, so they have like they use different algorithms. So based on these algorithms, actually their performance also varies. So a lot of research has been going on, like for example, like which one will be suitable, or how good we can store and retrieve, so that the performance will be faster. So this will be like a vector embedding. I hope got uh, um, some idea, means I'm able to explain a little bit about this embeddings and the search. So next we'll see about chunking. So in the beginning I was telling like chunking is nothing but like a splitting the document into the different units, or which we called as chunks. So because can be very big, like maybe 50-page document or 100-page documents. So mostly for processing, and storing and processing. So mainly actually we try to split the documents. So the splitting actually is based on this chunking. So this one will be like based. Uh, 16. So this this chunking is nothing but like a, which we call like some unit of information. So that is vectorized and stored in the database. And why it is required? It will be also for performance. Like chunking is also important for optimizing the rack, so we can process it. So using short chunks, you can add information from more chunks to the LLM. So here actually one more question is there, like what will be the ideal chunking size, or like for example like 1,000 or 2,000 tokens when you say that. So that will be like there will be some trade-off. So your chunk should not be very small enough, or it should not be very large enough. So that will be so for example, like if you are using very short chunks, then you can add information from more chunks to the LLM. So if it is short, then okay, it will has to lot of chunks you are adding. And however, it may lead to insufficient contextual information being passed on each result to the LLM. So assume, for example, you have 1,000 tokens are there. Now your chunk size is very small. For example, assume you have chunks will be only 5 or 10. Then when you are passing to those LLMs, maybe you will miss some insufficient or contextual information. So that is one of the demerit. And if your chunks will be very large, like larger chunks mean like very few chunks would fit into the context window of the LLMs. For example, like your chunk size is 500. Now you have only 1,000 tokens. Now that means only two chunks will be there. And for example, we know like in LLMs, actually there will be some context window or the at a time like how many tokens it can fit into the memory. So that is there, some limitation is there. So if these chunks will be very big, then it won't fit into the LLMs. And also like the bigger the chunks, actually it incur more cost. So that's the reason like you need to figure it out, like what will be the ideal chunking. So when you are splitting, actually if you see, we can also see like how we are splitting. So when we split, this is a parameter we are specifying, like what will be our chunk size. So next comes to the retriever. So this retriever is the main major components of RAG. So there are different retriever techniques are there, like how we are retrieving the documents. So I have some of the popular retriever techniques I have highlighted here, like parent document retriever or self-querying or web search retriever. So these are some of the retriever algorithms. So first, we'll go through like each one by one. Like for example, like a parent document retriever. So parent document retriever, it will be like try to strikes the balance by splitting and storing small chunks of data. And small chunks of data means if you look into actually the right hand side, this will be the architecture of the parent document retriever. So here actually it will be in two part. Like if you have a original document, so original documents will be first split into parent chunks. So like here it is like p dot chunk 01 or p dot chunk 02. So these are like first split into parent chunks, and then each of the parent chunk is again splitting into the child chunk, like c dot chunk 01, c dot chunk 02, like this. And whenever it will try to retrieve something, then it will, if you look into during the retrieval, so first it first fetches the small chunks, but then looks up the parent IDs for those chunks and return those large document. That means whenever we're trying to retrieve, first it will retrieve these small chunks, and looking into the small chunks, it know like which are the parent chunks, and it will return them the parent chunks. So that will be the whole idea. And the parent document refers to the document that is small chunks originated from. That means if when we say that, for example, the chunk iterative chunk 04, that means we know that the parent chunk of chunk 04 is this one, p chunk 02. So or the parent chunk, it will retrieve the p chunk 02 based on this chunk 04. So this can either be the whole raw document or the larger chunk. So in this way, actually the performance can be improved. So that will be like whenever your documents are quite big, so maybe you can go for this parent document retriever. That one will be helpful. Similarly, like some retriever we call like a self-querying. Like a self-querying retriever is one that name suggests has the ability to query itself. So this one is the self-querying. Similarly, like we have something called web search retriever. So where, for example, like you want to search some content from the web, then maybe we can go for web search retriever, where it will formulate a set of related Google searches, and it will retrieve from load all the resulting URL, and from the resulting URL, it will try to fetch for the similar search with the query on the consolidated page content. That means from each of the like the URLs, it will try to fetch the content or similar contents. So this will be like in web search retrieval. So maybe in one of the retriever we'll see during our demo. Like maybe I'll go for a parent document retriever and see how it works. So the main idea is like assume you have data. So and this retriever actually basically it will try to fetch the context. So uh, so whenever it will try to fetch the context which context, then uh, how good the context is, and based on this context actually the LLM performs. That means this retriever actually quite important for RAG. So okay, now till now we discussed mostly about the RAG, different components of the RAG, and also the retriever. But how we can evaluate the RAG? Like for example, the evaluation part is quite important. Like how to measure whether it is good or bad. So that is a part of the RAG evaluation. So the in the right side, if you look into the image I have taken from this website, you can go through it also, DeepSeek. So now we are talking about this retrieval. So and there will be two major parts involved here. One is the retrieval part, and second part is the generation part. So when we are trying to evaluate it, the evaluation also like in two phase. First one is the retrieval evaluation, and second one is the generation evaluation. So retrieval evaluation, it involves like whenever you have passing a query, so you are retrieving some documents. So those documents so those documents actually based on the retrieval or the retriever. So we want to measure the performance of the retriever. And in the second phase, in the evaluation, we'll see the response evaluation, like the output, like whatever the output you generate. So what is the quality of the output? So so that's why actually for each of the sections, there are different matrices involved. Like first we'll go through like the retrieval. So for retrieval evaluation, actually we measure those based on the hit rate or mean reciprocal rank, MRR. Or when we talk about the generation or the generator evaluation, then we can go for the correctness, faithfulness, or relevancy. So these are like matrices which use for measuring the RAG evaluation. We'll go through one by one. So first we'll go through the retriever evaluation. So we measure it like, for example, the heat rate. So heat rate is nothing but it calculates the suppose for example, like you have a queries, and you have retrieved some more documents. So we need to know that, okay, in the in the retrieved documents, like whether it is the correct answer is found or not, like or all the documents which we retrieve, if it any of the documents, so it contains the correct answer, not. So that actually uh, 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 that is actually this heat rate measures that one. So heat rate calculates the mainly the when you are the queries where the correct answer is found within the top k retrieved documents. So k, as I mentioned, k can be configured. For example, like you are retrieve top 5 documents, so whether the correct answer lies in the top 5 documents or not. So that is called like a hit rate. And similarly, we call it like a mean reciprocal rank, or which we call in short form MRR. So this MRR is useful when your primary concern is that the relevant result appears as high up in the list as possible. So high up means here you can see one example here. So there are like two relevant documents per query. So reciprocal rank asks how high up is the first relevant items. First relevant items means for example, here your K is equal to 1, 2, 3, 4, 5, like 5 documents. So high up means like, for example, like the this blue color, actually it represents the relevant items, because from all the documents which are retrieved, so those may not be relevant to your queries. So how good it is, or in the how top your relevant document is. So for example, here like you can see that there are 2 relevant documents per query. So for each query, there are 2 relevant documents, and how high up is the first relevant document. So here you can see like in the first, like here the first document contains the relevant document. So okay, we can call like 1 by 1 equal to 1, or this will be like the mean reciprocal rank. So rank will be here. So here, like in the first document, it will be like in the second phase, or in the here the first or the relevant document at the fifth item or the fifth place. So it will call like 1 by 5 or equal to 0.2. So here actually we can call it like 1 means it will be like 100%, because in the first document it retrieve contains your relevant items. So that's actually, and when we can call like mean, then if we have uh, calculate the mean, here it will come like 0.7, 0.57. So we can say that, okay, the mean reciprocal rank is 0.57 for for the retrieval evaluation. So this will be like some of the matrices to measure like the retrieval performance, we can say. So next, okay, as I say, there will be like two kind of evaluation. One is like the retriever performance, and second one is like the LLM performance. So in the retriever performance, actually only we measure the retrieve document, like how good or bad your the retrieve documents are. And in the second phase, actually we evaluate the LLM performance, like the output, mean the response, like how good or bad your responses are. So next we'll see that. So that for response generation, actually there are different different matrices are involved. Like some we call like some traditional matrices, like which we call cosine similarity, which will help to understand like how similar two vectors are. So, so like for example, you have your ground truth and you have your answers. Then we can calculate like in the cosine similarity, like how close they are. So that one will be, we can call it like a cosine similarity, or we can call like also we call bot score. Like we'll also measure the bot score, like it will evaluate the semantic how close they are. So using bot score, that is also another matrices. And also like apart from this cosine similarity or bird score, people are also using LLM based matrices. So LLM based matrices means these matrices actually internally use large language model for to evaluate it. So one of the example of LLM based matrices, like we call like ragas. So ragas, like it will be LLM based matrices. So here actually we call we calculate the Raga's score. So here also, if you look into, there will be like two parts are involved. Like one is like the retrieval, as one is like the generation. So in the retrieval, actually, we call like the context processor or context recall. So this one will be mostly measure the context. Like for example, like context precision. This science the noise ratio retrieve context or context recall can retrieve all the or retrieve all the relevant information required to answer the questions. That means whenever you are retrieving some context, whether this context is enough to answer the query or not. So that one will be in the retrieval part. In the same, like in the generation part, like once you have the generated some answer, like how good or bad the answer is, like faithfulness, like how the factually accurate is the generated answer. So for example, like you are asking a query is related to history or in a financial domain. So here the factual informations are quite important. For example, it should not only retrieve the answers, but all the facts or the numbers involved in the answer, that also should be correct. That means, for example, if you are asking a query like what will be the growth rate for 2021, if it is 35% and your answer is like 34%, then the answer is wrong in the sense like the facts are not matching. Or for example, maybe it will be for some factual information like instead of 10.5 it is going 10.3, then that also not correct. So those things actually will mostly check like the unfaithfulness also, and like answer relevancy, how relevant is the generated answer to the questions. So that also will evaluate in the generation part. So those are like some of the evaluation matrices. So next maybe we'll see like how these are working, or some demo we'll see. I'll give some example like this with some example like faithfulness, like mainly as I was saying. So you can see like the question like where and when was Einstein born, and the context where context you are passing is like Albert Einstein, born on 14 March 1879, was a German-born theoretical physicist, widely held to be one of the greatest and most influential scientists of all times. And the answer, for example, high faithful answer will be like it should be match with the exact date of birth. Einstein was born in Germany on 14th March 1879. And low faithful answer will be Einstein was born in Germany on 20th March 1879. Although the although it has some correctness, but the date of birth is wrong. So um, the fact is not correct. So mostly we need to see that okay, all the facts in the answers are correct or not. So this mostly measure the factual consistency of the generated answer against the given context. So mostly it is calculated from the answer and the retrieved context. So similarly, excuse me, answer relevance, like how the relevance uh, the answer is. For example, you can see a example like if, where is France and what is its capital. The role relevance answer will be like France is in Western Europe, and high relevance answer is France is in Western Europe and Paris is its capital. Because so mostly if you look into the questions where we have actually two questions are involved here in the main questions, like first is like where is France, and second is like what is its capital. Okay, in the first answer, okay, maybe it tells about France is in Western Europe, but didn't tell anything about what is its capital. So that's why actually the first answer is the relevance score is low, and second is the relevance score is high. So it will access like how pertinent the generated answer is to the given prompt, and a lower score is assigned to the answer that are incomplete or content redundant information. This matrix is computed using the question and the answer. Similarly, for context precision, that evaluate whether all of the ground truth relevant items present in the context are ranked higher or not. And mostly like whenever we are retrieving some of the context, so we have to see that okay, the ground truth is present in the context or not. And ideally all the relevant chunks must appear in the top ranks. This matrix is computed using the question and the context. In the top ranks means if you remember the example, so for example top ranks means we are talking about this one, like whenever you are retrieving the context, so the answer should be present in the top item in the context. Like for example here. So so context relevance. So this matrix also uh, uh, actually it will take like the relevancy of the retrieved context, calculate based on both the questions and the context. So here we can see in an example, like for example, the question is what is the capital of France? The high context relevancy, it tells okay, France in Eastern Europe encompasses medieval cities, alpine villages, and Mediterranean beaches. Paris, its capital, is famous for its fashion house, classical art museums, including the Louvre and monuments like Eiffel Towers. And low context relevancy is France in Western Europe encompasses medieval cities, alpine villages, and Mediterranean beaches. Paris, its capital, is famed for its fashion house, classical art museum, including the Louvre and monuments like the Eiffel Tower. The country is also renowned for its wines and sophisticated cuisine. So this is actually lot of things are given, but it's not. Uh, 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 it's actually apart from the questions, actually the queries, it actually contains many information which are not exactly or the relevant. So that's why we in the first answer we say the relevancy is score is high, and in second it will be low. So ideally the retrieved content should exclusively contain essential information to address the provided queries. So when we talk about like the capital of France, okay, this will be like maybe we'll say like the what is the capital of France. So we are talking about like the capital, and maybe we can the related items relating to that particular capital. But in the second, okay, it talks about capital, but also it has a lot of information which are not relevant to the query. So that's why the context relevancy is low. So, and these actually, it's not very easy to calculate with the traditional matrices like a bot score or similarity score or cosine similarity score. So that's why actually these LLM-based matrices are more useful. And that's the reason like nowadays actually for RAG evaluation, people are using mostly these LLM-based matrices. But at the same time, this LLM-based matrices is a little costly because costly in the sense, first thing is that it will pass to the LLMs. For example, like if you are this matrices use OpenAI key, and again you have to pass the OpenAI key, and internally it will create prompts and query using LLMs. So that's why actually it will consume more what you can call your usage, and uh, uh, incur more cost. But at the same time, so you'll get more accurate answer. So that is there. And last one is like we call like the context recall. So mostly actually it will compare with the ground truth. It computed based on the ground truth and the retrieved context. So here, here is the France and what is its capital. So ground truth is like France is in Western Europe and its capital is Paris. So this will be like the high context recall. So mostly it will tells like the your context, like how aligned with the annotated answer, and comparing with the ground truth. So if you look into the high context recall is like France is in Eastern Europe, encompasses medieval cities, alpine village, and Mediterranean beaches. Paris, its capital, is named for its fashion house, classical art museums, including the Louvre and monuments like Eiffel Tower. And this will be like low context recall, like where it tells France is in Western Europe, encompasses medieval cities, alpine villages, and Mediterranean beaches. The country is also renowned for its wines and sophisticated cuisine. So it will it will not only tells about the capital, but it will talks about many things. Actually, those are not in the ground truth, or it will be not aligned with the ground truth. So, which we call like this will be the context recall. It's a very low context recall. Mainly, so for calculating this, what you need to do, you need to pass like the questions, ground truth and the context, and based on that, it will generate the score. So that's why we call like it is computed based on the ground truth and the retrieved context. So these are the matrices like already we discussed, like the Raga score, which is one of the LLM based matrices, and which has some advantage over to traditional cosine similarity and bot score. So I think we have got some details. So next we can have some demo. So here actually we have some references I have added based on this, whatever we have discussed. So before proceeding to the demo, so in the demo actually we'll see a like a GPT model, like we'll try to build some document like the data, and we'll retrieve some of the documents, and as the name suggested, like we'll do for like a Hindi, and this model also will use our own model, like we have a fine-tuned Hindi model, so using that we can see. So before going to the demo part, so is there any queries or doubt, or we can take it here, or maybe, or we can take at the end. I don't know how. So Dr. Satya, you have some suggestion?
If you have any query, then you can. No problem.
Yeah,
Okay, just
if
unmute yourself and ask the question if you have any. Shubhi, yes.
Hello,
Yes,
sir.
Shubhi. Hello.
Hello, yeah.
Yes, Shubhi,
Or
you can unmute yourself.
Or you can chat it, like if you it is you have some face some problem, you can type in chat, and Dr. Satya, he can ask me, no problem.
Yes, Shubhi. Shubhi, you can ask.
I think he might have
Am I
some
audible?
issue.
You are audible.
Yes,
You are audible. Just ask the question. I don't think so. Okay, anyway, Miss, at the end we'll take the query. Otherwise.
Yeah, we can take at the end, no problem. We have some time for question answer. So yeah, so in the demo actually we'll use an LLM. So this LLM actually so this LLM actually we are using a Hindi GPT model, like which will be trained by us, and it's a fine-tuned model. So this model actually, model actually it can able
So,
to
Sandesh sir,
answer
one
like
question is there. One question is there
okay.
from one student where we can make augment in LLM. Where you can make augment in LLM and chat box they have given.
Okay, yeah. Thank you. Where you
Either we can
make
take now or
Oh
at the
yeah,
end we can take.
I can answer it. So where we can make augment in LLM. So actually this augment part, even if you look into the first architecture, actually we can see. So this one will be the like if you this is the LLM. Actually here actually we have the augment part. For example, in the if it is like in the normal without augment, then you can directly to the LLM. You can pass the queries directly to the LLM here, and you can get the response like normally like how uh, uh, we are doing in the LLM. But when we call it like a augment means, or we can say like okay, we can pass some additional information. So there actually this part will comes into picture, like where we are uh, passing some extra information in terms of context. So and this context, this context actually we are getting through these vector DBs or fetching the relevant context. So like from the queries, actually we are trying to send the query embeddings and try to get the relevant context and pass to the LLMs. So the idea is like that, okay, if you pass to the normal, like the query to the LLM without any context or any augmented or additional data, so the LLM, whatever the information with the LLMs, you can only get that response. So if the LLM is not up to date or it doesn't have those knowledge, then you won't get those answers, or answers may be wrong. But whenever you are passing like some additional information, then LLM has the knowledge of the the large language model. It has already trained with the data, so we can uh, we can we can use both like the context and the large language model, and it can get more precise answer. Uh, uh, the next one, we can do it as an DBMS. Yeah, actually this one actually you can create as a you can create as like a DB. So this vector DB is nothing but like a normal database. Only the difference is like that in the normal database you are storing different type of information, whether it will be like a numerical data, like it will be string or numbers. So here only you are storing the embedding. So that is the only difference. And otherwise it will be same like your vector data, sorry, your DBMS or the data. How do we evaluate an LLM output? Yes, actually that part actually I have shown here how to evaluate the LLM output. For evaluation the LLM output, actually we use this uh, how to evaluate? Okay, this for evaluation of LLM output, actually we are using this generation part. So this generation is nothing but the LLM output. Here actually I have shown the generation evaluation. This correctness, faithfulness, or relevancy. Actually, these scores are nothing measure the LLM output. I hope that part is clear, because here I already mentioned, like one is like we are measuring the retrieval performance and one is the LLM response. So this LLM response are measured using these matrices: generation, evaluation, correctness, faithfulness, and relevancy. How to evaluate as it is as it SQL commands.
SQL command means
Actually,
what?
it's actually here we are not using this not in SQL commands actually. Okay, I can show you like how the LLM
You have
works in the
written that
demo. Yeah.
DB, vector DB, that's why they have asked me.
Okay, no problem. Actually, yeah, maybe, yeah. So this will be okay. I'll go through those also details, like how it will store. Although it is called the vector DB, so it will store likely directly we are retrieving the text chunks, and those chunks actually we are get the embeddings and stored there. So it will be not we are storing in SQL, but it will be like similar to some text-based database we are storing. Only thing is that like you are storing embeddings. Anyway, in the demo, I'll show you. So hope you'll be clear on that. How we are retrieving and storing in the database. But no problem. If you have any question, feel free to ask me. Yeah, so just saying. So this so this model actually based on a Hindi GPT model which we trained. Yeah, maybe can go through it. So this model already we trained this model in Hindi. So we'll for the demo I'll use this model. So if you know, okay, this model, it is just a LLMs like which I've already trained with a Hindi instruction set. So it can so it has some ability to answer the questions. For example, you can ask like maybe many people don't understand Hindi. I can translate it. For example, in the first questions we are asking like what is the capital of Mexico city? So it can able to answer like for example many of these queries. Like for example, we can it can able to answer like if you ask write a program or different domain. For example, here we are asking like can you write me a Python program? So it can able to write a Python program. So if you try to ask any queries, then it can able to answer. So this data, sorry, this LLM actually we used our own instruction set. So data set we built and also we fine tuned this model. So this model is a Mistral model, like using Mistral 7B, we fine tuned the model. So why I'm showing actually this model actually we'll use for our demo, like we'll try to load this model, and use this model we are passing some context, and then we'll see like how it generate the response. So as you can see, like this model can have capability to understand different queries which you can pass in Hindi, and it can able to generate generate the response. So you can means this will be like for the Hindi, but we have like fine-tuned models in different languages like Odia or Bengali. So you can, for example, you can use any of your any fine-tuned model. So only thing is that okay, you have to prepare some data set, and then we can fine tune a model. So that one will be a different topic altogether. So I'll not go through it, but so that will be like a LLM fine tuning. So, but I'll go through the mostly the RAG part. Like for example, as you have a model, and how you can use that LLM to generate the response using RAG. So yeah, I think this we have, as we have seen, like for example, this model, it can uh, able to generate the response. But thing is like, can the model like able to answer correctly when we are passing any queries, like whether it will be like most recent queries or relating to some facts or information which the model might not be seen. So that will be the main challenging part. So okay, here we are asking like a different type of queries like about corona, like how we can fight with corona, or can you write a Python program? So you can see like it can able to answer correctly. That means it has some knowledge. So let me, yeah. So we'll use it. And for simplicity, actually, I'll share the this one also, this collab notebook. So I have made such a way that you don't need a lot of computing power to use the demo. So we can run in Colab without any GPU also. This demo should work. Let me go through the demo. Okay. Yeah, so we're going to the demo. So what we are trying to do in this demo, so as you have seen, is there any... Okay, so there is some
Why wrong
question, so
answer
we
asking?
can okay. Why does a model totally give wrong answer after training, and where does it gets them from? For example, one time I fine-tuned two models, one for disease prediction based on symptoms from a data set, and the other for answering medical related questions using small data set. The first one worked but well, but the second one never gave me correct answer. It gave an output but totally different thing from the data set I imported using but. Okay, so there will be, as I said, actually in the beginning also I mentioned. So first thing is like when you are I assume you have done a fine tuning of the model. So when you are doing the fine tuning of the model, first thing is like you take a base model, like, or we can call it like the foundation model, and on top of the foundation model you are trying to use some instruction set for fine tuning. So first, what can be wrong? So first thing is like that if your foundation model doesn't have enough information relating to that particular domain, that will be one thing. Second thing is like you the fine tuning data, like how your instruction sets are like, is it like a really enough to, for example, you are fine tuning of the medical data. So whether the instruction set you prepared have covered all kind of related all kind of information which can help the model to fine tune properly to get the answer. So that one will be the second thing. And even if the both the model didn't work, so you can try with this RAG approach, like where you take your fine tune model and all this context, all the data which you are saying, you can pass through this and you can try it. Definitely it will work because if you are passing the context, then it will definitely give you the answer. But yeah, if you maybe can give some more background, like in which what will be your the foundation model and on which language you have tried. So then maybe I can give more concrete answer. But as I said, so those are actually the major issues. And even in the beginning, I was telling like what are the major issues in LLM. So if it is not have up-to-date information, then also the model didn't able to answer it properly. So yeah, so these are like some of the issues, your foundation model and all your data set. And also also it is quite important the fine tuning, like how did you fine tune? If your fine tuning process is not correct, then also it didn't able to answer it correctly. So that's the reason you need to check your learning curve, like whether the loss, you check the loss and try take a like a small eval set and try to use that evaluation set to check that okay your model or the fine tuning is working properly or not. So that is also quite important. So in this demo, actually, we are using a parent document retriever, so which track the balance by splitting and storing small chunks of the data. And as I have shown, like in the first retrieval, it fetches small chunks, and using the small chunks, again, it will look into the parent IDs and return the larger document, which I have seen. And the experiment setup, actually, the retriever we are will use like this parent document retriever. And for LLMs, we are using a Mistral 7B Hindi model. It will be trained by us, our model. And for embedding vector, okay, we are using this Flamini as embedding vector. And also you use OpenAI embeddings. So this one will be the setup. Second. Let me maybe let me go through the collab. So yeah, so first you need to install some the required tools and libraries. So I'll not go through in details. And here actually we are using ChromaDB for vector storage or the embedding, store the embeddings. This one. Yeah, so next I'll give very sample document, so it won't take a lot of time to run the experiment. So here, if you look into, actually here we have prepared some data. So data means it will be like the page content. So we have taken some content. Okay, the sources like we have taken from this Indic QA. So these are I hope my screen is visible to all. So these are so these are the page content. So we have taken like a 3 page content or uh, 3 document we can say here. And so first is like first we are testing the model, like means whether the model is able to answer correctly or not. That means whether first we test whether our model is working properly or not. So if you are running this experiment through Colab, then one issue you might face, like if you take a very big model, it won't load into the memory or based on your Colab, because everybody don't use this Colab Pro. So that's why I try to restrict the experiment so that everybody can run it. So it doesn't need any Colab Pro. So just a normal Colab, you can take it. And as if your model is big, so we have you know that you can do some quantization, like you can use 4-bit model or 8-bit model. So actually I am using 4-bit so that it can able to fit into memory. So this is the model. So just you have to specify the model ID. So the model is already available in Hugging Face. So I have given the model ID. And here if you are using a I am doing quantization, so that's why actually I made this load in 4-bit as true, so that actually I can load the model 4-bit model. So you can see like this will be the pipeline where defining the pipeline. So the model equal to 4-bit, this will be the tokenizer, and these are the required configuration, like max length is 2000 the tokens, and top k, as we have seen in the presentation, like already we talk about the k values. So k value I have given 5. That means okay, five documents can be retrieved, and these are the temperature. These are actually values set for the LLM performance. Yeah, so this is like a the configuration for loading the model. So first we'll try to load the model. So if you say it, you can see, okay, this debugger flag I set to true so that we can see the debugger. And this will be a simple template like for a question and answer. So here we say that, okay, we have given the below is an instruction that describes a task paired with an input that provides further context. Write a response that appropriately complete the request. That means we are passing a questions and the context, and we are expecting the response. So this will be my questions. For example, here in Hindi, I am asking something about what will be the date of announcement. So that will be my questions, and this will be the context. In the context, it tells about like a 10th August is the date of announcement, and they have some other contextual information is there. So this will be like my the prompt template where I'm passing the input variable as questions and the context. And here I am getting the response. So this one just to test the model, whether my model is able to response based on the query and the context. So you can see the answer, it can able to respond the answer like, okay, the announcement date is 10th August 2021. That means, okay, the model is able to load and model is able to answer. So next comes to the first phase. So first phase is like our embedding generation. Like first I'll try to generate the embeddings. So for embedding generation, actually I have used this multilingual mini LM. So because I am using mostly in Hindi text, so I am using this for embedding generation. So for embedding generation, as I was telling, first we have to, so here, okay, one of the, somebody asking about the DBMS part like SQL and those things, how we are storing in the database. So this one will be very simple. You can see like we are using the Chroma DB. So here actually we are specifying the text splitter. So for example, we are using this recursive character text splitter to splitting the characters. And you can store in your any of the directory, or you can store in your memory also. For example, I can store in memory. So this will be the text splitting and storing in the vectors. So as we have seen in this retriever, actually there will be two part was there. Like one is the child splitters. So this will be like where child splitters. So where we are passing the chunk size. So chunk size is 200. So in the presentation, I was explaining the importance of chunk size. So if your chunk size is too small, what will be happen? Or if your chunk size is too large, what will happen? So here to keep a balance, okay, we have taken chunk size is 200. And this vector store is used to index the child chunks. So this will be to store the to child chunks. It will be stored in this vector store. So here I am using this chroma db, and this will be my collection name, and this will be my embedding function. So this will be like this will be from a OpenAI embedding. So as I said, I will store in memory. So this one will be I am defining like a store in the memory, and this will be like full document retriever. Like here, if you see, there will be like a two one is like the we are defining the child splitter, like and also like for retrieving the parent document. So I am defining here the parent document retriever. So this is the vector store, and this one will be the child splitter. Already we have defined here recursive character text splitter to chunk size. So next is like we are adding the document, like a full document retrieve, add document. So we are adding the documents. So when we are adding the document, so you will get some keys. For example, like so these are the keys, or we have seen in the like in the PPT, like some identifier, like where we are getting the child chunks, and using that we are fetching the parent documents. Yeah, parent chunks. So for those, actually, we are using these keys. So and how it works, for example, like for sub documents, we are passing to uh, some text for a similarity search. For example, I am passing to vectors to dot similarity search. For example, it takes about some queries about when is the constitution of India uh, started. So here I am specifying k equal to 2, that means two chunks. So based on the similarity, it will fetch two documents. So here you can see like the sub documents, it will fetch two documents based on this text. So this length of document equal to, we are specifying k equal to 2. So we are getting two documents. And if you look into the page content, so you can see the page content. So also, for example, if you want to retrieve the full document, so this one will be like the small documents, like from the child chunks. Even if you want to get the full document, then you can uh, you can get from the full document retriever, get the relevant documents. So it can give you the whole document. And you can see the as in the we have seen like the child chunks always will be very small, but whenever you are retrieving the from the parents, the chunks will be big one, and the page content also will be larger one. So here actually the we are specifying the big chunks. So big chunk size we are specifying, like for example like 800. This will be like the parent splitters, and child splitter chunks, okay, we are specifying at 200. So that child splitter the so this one will be used for splitting the whole document into parent chunks of 800 size, and this one will be for splitting the child chunks, which 200. And always your parent chunks are big chunks, and child chunks are small one. And whenever you will start retrieving, actually you will start from the child, and based on the child, actually these chunks, it will fetch the associated parent chunks or the big chunks. So the vector store used to index the child strings, and as I said, we are storing in the memory. So this one we are defining the store in memory store, and this one will be the big chunk retriever. So whenever we are we are mentioning big chunk retriever, that means we are retrieving from the parent document retriever. So here actually we are specifying both child splitter and as well as the parent splitter, and here we can say the the keys and the length of the keys, like the number of document it retrieves. So this one, these are actually, I'll share the link, like the collab link to test it. Actually, this one actually we can play with it to see how it works. So next, we'll try to give some queries and see how it able to get the response. So this one will be like my the prompt template, same like I'm passing the question and the context and try to retrieve the response. So here actually I'm passing a query. So my query will be like a Jhansi ki Rani kaun thi? That means who is the Queen of Jhansi. So Jhansi means it's a place. So here, here I am passing to this. So here you can see that, okay, it can able to fetch the response like Rani Lakshmibai is the Queen of Jhansi. So, and some of the information about her. So you can see like how it works. So that means if you pass the context, and if you observe it, actually actually it will pass the context, and these contexts are nothing but if you look into the context, actually why it is able to accurately answer it, because based on the context. And if you look into the in the context, actually in one of the context, actually it talks about the or it actually it gets the relevant context, and using the relevant context it can get the answer. So that is as we have seen that, okay, if your context uh, you are passing the queries and the context, and if the context is relevant, that means if your context is proper based on the retriever, then definitely you will get the accurate answer. So that will be like we can see. But the next question is like, okay, how we can evaluate? Like for example, okay, we can get the RAG, but how to evaluate the RAG? So for the RAG evaluation, okay, I can show you a small example. Like for example, in a RAG evaluation, mostly you need a questions context, uh, ground truth, and your actual answer. So for example, like you have a this will be a questions, and it will be the actual answer, or which you call like ground truth, and you get some generated response. So so here actually I am using a small data set, like it is a again our data set, like in the test closed domain QA. So I am taking only a small split 10 to get it. So the data set will look like this. So it has some context. It has context, and it has some yeah, go through. Okay. It has context. Context is long, and it has a questions, and it has a answer. Uh, so yeah, I have taken a small split. So if you look into, okay, uh, so already the LLM already we have defined. So I'm not defining the LLM part again. So for simple response, then you can just generate the response. Like for each of the questions, okay, you can get the response, and we can save into you can save into Drive, or you can save into any data frame. So if you for example, I have saved into Drive, then it will generate the response, like 10 questions I have specified. So the response are stored. So For easy, if for first purpose, actually I have already the response are there, so I just load those response. So it will be look like this after generating the response. Like you have a context, you have a questions, and this one will be your actual answers, and this one will be the generated answer. So actual answer is nothing but your okay. I just rename it for easy purpose. So your actual so your actual answer is nothing but your ground truth, and this will be the answers which your LLM has respond. So now we can compare it. For comparison, okay, there are, as I said, there are different matrices. Maybe we will start from the bot score. So for easy calculation, okay, I am adding into a list. Like this will be like a context list. This will be question list. This will be answer list, and this one will be the data. So mostly ragas actually they use in this format. So I just make a data set in this format. So data set of being question, context, answer, and ground truth. So first we will calculate the bot score calculation. So bot score calculation is simple. Like I have installed the bot score. And here actually we are evaluating the bot score. So like we have the prediction is nothing but your answers, and this one will be the reference. These are your ground truth, and the language I am using is Hindi. So we can see like we can calculate the uh, mostly the precision recall and F1 score. So this one will be the precision recall and can call the F1 score. You can calculate. Similarly, you can calculate cosine similarities. And if you want to use Ragas, then you need to install Ragas, and you need actually OpenAI key. If you specify your OpenAI key, then I'll just show you till it's simple. Like if you have to pass the data set, question, context, answer, and ground truth, then you have to define the matrices here, like context recall or context precision or faithfulness. So whatever the matrix you want, you can define it here, and then it can calculate it. But only thing is that you need a OpenAI key, and sometimes this free version of OpenAI key may not work. So based on the rate limit. But yeah, even if it is not Ragas, you can calculate like the embedding score, but score or cosine similarity. Uh, yeah, I can share this one for your practice. So I don't know how much time. So Dr. Satya, we have some time. How much time we have left? You can see some. Hello? Hello? Hello?
Somebody asked about to share the Google that collab link.
Yeah, I'll share. So we have some time to take questions.
Yes.
Okay. Yeah, so maybe yeah, if you have some, yeah, I'll share the collab link so that you can practice it, and it doesn't need any collab pro or anything, so you can load the model and you can see it. But yeah, if you have any queries, we can take some
If
questions.
anyone
So
having any queries, then ask to Shanti sir. If anyone interested to work on this LLM or this model, okay, or in this domain, then definitely you can directly contact to Shanti sir. He is going to share the links now here. Otherwise, you can also contact with me. So that through me also. So we are collaboratively working for last so many years. So we can work. Okay. If any question from any participant side, then you can free to ask. Akanksha, any questions? Because everyone is going for this nowadays, generative AI, this LLM. Okay. So lots of projects are there. You can do in this area.
yeah, you can, yeah. So if anybody is interested for working in the this domain, yeah, feel free to contact us. So Satya sir can provide the details. But yeah, for example, like if you want to interested for in your domain or in your language, then feel free. because we have already prepared the data set, we have built models, and also we have built
You
many
can
tools
also
for data preparation.
design some tools as for your last semester project. If any final semester students are there here from KIT or outside KIT, so you can make some projects like your, suppose you are not interested for the research project, it's okay. You can design some tools, all the things you can design by using this in this domain you can do. Okay. Anyway, I will take the feedback in details. Okay, and then I will share with Santi sir. If anyone is interested, then definitely I will inform to Santi sir. And you can also directly contact to me or Santi sir. If no questions are there, then we'll stop here. And if Santi sir share the link, Google Colab link, I'll share with you.
Yeah, I'll share the PPT and the collab link to Satya, no problem. And thank you all for joining the session, and hopefully it have some basic idea I am able to convey. And feel free to ask for any queries or contact me. I'll provide the details. So thank you, Dr. Satya, so for inviting me, and I'll share my details. So if anybody has any questions, they can.
Yes. Thank you, Dr. Sandy. And it's been a nice presentation, and definitely it will be helpful for our students. If our students are outside students also, because many of our India students are not joining, but abroad students are joined here. So definitely, if they are going to contact me, I'll inform. Thank you.
Okay.